Hello and welcome to our third lesson of the chapter. This is section 1.3, combining transformations of functions. So in the previous two lessons, we've looked at how we can move a function up, down, left, right, and how we can expand or compress a function or stretch it or squish it, and how we might be able to reflect a function. So far you have done left, right, up, down together, and expansions, compressions together. Today we're going to be putting all of these things together. So you might have to do all 5 of those at once. You might have to move left or right, and up or down, and expand or compress your x values, and expand or compress your y values, and reflect. You might only be doing 1 or 2 things at a time. You might be doing all of them. So the first thing that you need to be able to do is identify from a function what transformations you are being asked to perform, and then perform those. Okay, so a reminder that you will not always be given an actual function. You might just be told you have some function f of x. Now here are your transformations, or do these transformations. You might also be given a graph, such as the one you can see on my screen here, where we don't know the actual equation for these functions. We're just saying these are some functions f of x, and we're going to perform some different transformations on them. So before we start actually performing all of these transformations together, in case you didn't do your self-assessments for 1.1 and 1.2, we're going to do 2 review questions here. The first one, we can see we have a 1/2 in front of our function. We have a x over 2, which is the same as 1/2 x inside of our function. And we have a negative in front of the function. So the negative outside the function, a reminder, this is a vertical reflection. We can write this as VR. The 1/2 in front of the function would be a vertical expansion by 1/2. Okay. X over 2 is the same as saying 1/2 x, which would be a horizontal expansion by 2. So we need to perform all of these operations. So all of our y values are going to get multiplied by 1/2 and reflected. All of our x values are going to get multiplied by 2. So again, I like to start from the left, work my way to the right, and connect as I go. If it helps you to write a table of values to help you, you can, or even a list of the ordered pairs and then perform the operations. That works as well. So if I start at this leftmost point, my y coordinate here is a 0. So if I reflect that, it stays at 0. If I times it by 1/2, it stays at 0. So my y coordinate will not change. My x coordinate, however, is a -6, and I'm being told I need to multiply that by 2. If I take -6 and multiply by 2, I get -12. 7, 8, let's say 9, 10, 11, 12. So it's going to be way off my grid here. Okay, so my original one here was -6, 0. My new one is at -12, 0. So on a test, for example, you would not need to write those ordered pairs, but you might find it helps you with graphing your new function. My next point here, this point is at -2, -2. So my x coordinate, I need to multiply by 2. That means my new x coordinate will be -4. My y coordinate, I need to reflect. So instead of being at -2, that will now be a +2. And I need to times by 1/2, which would give me 1. So my new x coordinate will be -4, and my new y coordinate will be 1. And then I would suggest connecting those points. So again, we took our x-coordinate and we had to multiply by 2. We took our y-coordinate, we had to multiply by half, and we had to reflect. So if I multiply by half, I get -1. If I reflect, that gives me a +1. I'm going to zoom in just a little more so it's a bit easier to see. Okay. My next point is this guy up here. This current coordinate here is 0, 4. Horizontal expansion by 2. That means I'm taking the 0 and multiplying by 2. I'd still be at 0. My y-coordinate is a 4. If I take that and I multiply it by 1/2, I get 2. And then if I reflect that, it becomes -2. So it's going to be down here. So again, if it helps you to write down the coordinates of the point, you can do that. Okay. So what we did here, we took this one and we multiplied by 2. We took this one and we multiplied by 1/2, and we did a vertical reflection. And the last point, this one currently has a coordinate of 2, -4. So if I take the x-coordinate 2 and multiply by 2, I get a new x-coordinate of 4. If I take the y-coordinate and multiply by 1/2, I get -2, and reflect it, I get +2. So my new coordinate is going to be at 4, +2. Again, we took this one and we multiplied by 2. We took this one, we multiplied by half, and we did a vertical reflection. Okay. So as we can see, this has been squished so that it's shorter than it was before. The vertical distance doesn't span as far as it was before because of the compression by 1/2. It has flipped vertically. That's my vertical reflection. And it is stretched out further horizontally. That's my horizontal expansion. My next one, I'm going to choose to rewrite it. I don't like having the 3 on that side. And so the 3 at the end here, this means up 3. Or you can say vertical translation by 3. The 2 inside the function with the x indicates left, right. Because it's a +2, this is actually going to be left 2, or you could say horizontal translation -2. Fix that arrow there. Okay. Again, I would work your way left to right. We need to move everything up 3 and left 2. So this first point here, if I go up 3, 1, 2, 3, left 2, my new point will end up here. Up 3, 1, 2, 3, left 2, our new point will end up here. Connect the points. The next one, up 3, 1, 2, 3, left 2. Connect the points. The last one, up 1, 2, 3, left 2. Connect the points. Okay, so every point is just moving up 3, left 2 each time. Okay. Again, if it helps you to make a table of values or write down the ordered pairs and then write where the new ones end up, that works as well. But it is a lot more work than just going off of the graph. So the next one, what we're going to do is we're going to be combining all these transformations together. Okay, so we can see here we have from the -1/2, this is a vertical reflection and a vertical expansion by 1/2. That's what we just had. Okay. This 1/2 here is a horizontal expansion by 2. It's inside the function with the x. As soon as it's inside the function with the x, it is a horizontal change. Okay. This +2 here is a left 2, and this +3 at the end is up 3. When we are doing these transformations, it is very difficult to do them all at once. chances are you will make some sort of small error or you will lose track of something that you either have done or not done. I highly, highly suggest that you go in a specific order. The order does matter. You need to do any vertical or horizontal expansions, compressions, reflections first. Then move left, right, or up, down. What I would suggest is drawing what I call a ghost graph. What that means is I'm going to do any expansions, compressions, and reflections and draw where that would go. Make sure I've got it, and then move that new graph left, right, or up, down. You will have less room for error. You are less likely to make a mistake. Okay? I would do it either in a different color, maybe in pencil. I tend to use a dashed line. Okay? Just make sure it is very clear, for example, on a test, which one is your final graph. Make it darker, label it properly, highlight it, something. Okay? That way also, if your final graph is wrong, but your mid graph is right, I can give you some part marks. I can say, okay, they knew how to do the expansions, compressions, reflections. They just got stuck on the left, right, up, down. Or they made a small mistake when they moved left, right, up, down. It's easier for me to catch your errors and give you more credit for what you do know, okay? Because it is more clear what your process is, all right? So if you've noticed, these are the same transformations we just had up here, okay? Right here, we can see the 1/2. Here's our 1/2. Okay. Here's our 1/2 inside. Here's our 1/2 inside. Okay. We've got our left 2, and we've got our up 3 here or here. Okay. So it's all the same transformations that we just did. Okay. What I'm going to do, that means for my blue and yellow highlighted ones, the 1/2, 1/2, and the minus is the same as our very first graph we just drew. So that's going to be my ghost graph, okay? I'm going to do my expansions, reflections, compressions first, okay? I'm going to draw those on, and then I'm going to use a dotted line to indicate those and move that left and up, okay? So I'm going to do these second. So first, again, if I start at -6, if I reflect that vertically, it doesn't end up anywhere because the point here, again, was -6, 0. So my y coordinate is not going to move. My x coordinate, I'm multiplying by -6. That means it's going to end up, -6 times 2 is going to end up at -12. So I'm going to erase some of this stuff here just so it's out of the way. Let's move this. Okay, so -7, -8, let's say -9, -10, -11, -12. Okay, my next point here, okay, this is -2, -2. So this is what we just did earlier. So if you want to skip ahead till you see my dashed line, you can do that. Remember, it's a video. You can move around as you need, okay, or you can speed it up. We did just graph these first 3 transformations up above, so you can also just copy that graph you just drew there. Okay. So the -2, -2, again, x needs to multiply by 2. That's going to give me -4. The y needs to multiply by 1/2 and flip. That means I'm going to end up at 1. So my new point is here. Okay. And this is -4, 1. Third point here, the coordinate here was 0, 4. That means my x coordinate will not change because I'm multiplying 0 by 2. My y coordinate needs to be multiplied by 1/2 and then flipped. That means I'm going to end up at -2. I didn't draw my dashed line, so I'm going to draw this as a dashed line here, just so that I remember I'm not done. My last point here is at 2, -4. So again, my x coordinate multiplied by 2, that gives me 4. My y coordinate multiplied by 1/2 and flip, that gives me 2. My new point is at 4, 2. Okay, so this one in black, . is after my vertical expansion by 1/2, my vertical reflection, and my horizontal expansion by 2. It is not my final graph. I still have to move this left 2 and up 3. Okay, so my farthest most point is over here. If I move that left 2, I'm going to end up at negative 14. I'm not going to graph that. Okay, it's way too far off my graph. Okay, so I'm going to go for this one next. Okay, this one here, if I move it left 2, it's going to end up at negative 6, and then I need to move up 3. It's going to end up at 4 right here. And I know that this would have gone off in this far direction, way down towards negative 14, an x value of negative 14. So it's heading off that direction somewhere. Okay. Next, I'm going over here at this point. This has an x coordinate of 0. I need to move it left by 2. And then it has a y coordinate of negative 2. I need to move it up by 3. So up 3, left 2. It's going to end up right here. Again, I'm going to connect my dots. Okay. Last point here, I need to move up 3, left 2. It's going to end up right here. And I'm going to connect my dots. Okay, so the blue one is my final graph. Okay, so all I've done is I have taken that dashed line and moved that one. So the dashed line we can see has all these different expansions, compressions, and flips going on, but my blue line is simply a movement of the dashed line. So again, the dashed line there, I call that my ghost graph. So if you hear me say that, that is my in the middle of the question graph. I'm not done. It's there to help me then move left, right, up, down. To try and do all those transformations at once to each point is a lot, and you will likely lose something in the process and something will go wrong somewhere. So I would highly suggest doing this. Expansions, compressions, reflections first. Draw yourself a little ghost graph and then move that left, right, up, down. So that's my hint in the box at the bottom. Okay. Do expansions, compressions, reflections first. And I would say draw a ghost graph of where you end up. Okay. Then move left, right, and up, down. Okay. So one of the things you might do is what we just did, where you're given the graph, you have no actual function. You don't actually have an equation you can use. You can't just build yourself a table of values. You have to know the rules, okay? So I take my graph, I move that around, okay? The other thing you could see is simply, I have this function and I have a single point that I'm moving. We're going to do the same thing. Figure out where that point would go after expansions, compressions, reflections, then remap that point to another location, its new final location after moving left, right, up, down. So the first thing we need to do is we need to say, okay, what's happening here? Okay, I've got this guy here. This would be a vertical expansion by 1/2. This affects my y values. Okay. I also have the +2 at the end, which would be up 2. This also affects my y values. Okay. So that's going to affect the 4 in my coordinate. Okay. I have this 2 that's inside the function. That means that is affecting my x values. So this would be a horizontal expansion by 1/2. Remember, it's not intuitive for the x's. Says 2, that actually means 1/2. This affects my x values. I also have the -1 in the brackets with the x. Okay. This also is going to affect my x values. This is my left right. It says -1, so this is actually right by 1, and this affects my x values as well. Now, just be very careful as you're looking at the functions in this format. If I have something like y equals 2 f of 3x minus 6 plus 1, this is not moving right by 6. Notice the difference between this and this. There are two sets of brackets in the question that we've been given, and in the one I just wrote out, there is only one set of brackets. In order to determine our movements, we have to make sure that any coefficient in front of the x is factored out. Okay? So you need to make sure any coefficient in front of x is factored out before determining left-right values. Okay, so we already have that in our question. The 2 is factored out of the brackets. The x minus 1 is in its own little set of brackets there. So that's why we can say that this has moved right by 1 after it has been horizontally expanded by 1/2. So once I have that, I know that I'm starting at 2, 4. And I'm going to start by doing my vertical expansion by 1/2 and my horizontal expansion by 1/2 and determining where this ends up. Okay. If I had any reflections, I would do that now as well. So my x coordinate is 2. If I multiply that by 1/2, I get 1. My y coordinate is 4. If I multiply that by 1/2, I get 2. Once I have my new point on my what would be my ghost graph, I can map that and do my up 2 and my right by 1. If I move right by 1, my new x coordinate will be a 2. If I move up 2, my new y coordinate will be a 4. So on this graph specifically, it happens to end up that we have moved back to where we started. Okay. If we were doing a general mapping for any point on this graph, if we started at xy, our new point would be at half x, half y for our vertical expansion and our horizontal expansion or compressions by 1/2. And then if we move up 2 and right 1, we would end up at 1/2 x plus 1. Ooh, I'm going to run out of space. Let me just write this a little smaller. And we would end up at 1/2 y plus 2. Okay. So again, that was our mapping notation. All right. So you might be given a graph and a f of x with some transformations and asked to draw a new one. You may be given a single point and an f of x with some transformations and asked to find the new point. Okay. You might also be given something like this, where I have given you the graph of root x, which is this one. Again, that's one of our basic graphs that we want to make sure we know. And we are given this new graph here after some transformations. And our job is to figure out what those transformations are and write a new equation for this graph. A lot of people find this very difficult. They don't know where to start. They're not sure, well, was that a movement left? Was that some sort of expansion? And they find it difficult. Okay. These ones will take some practice. My first hint would be, what point will not change if you expand or compress it. The only point that won't change if you expand, compress, or reflect is the origin. If y is 0 and you multiply that by some value or try and reflect it, your coordinate will still be 0. If x is 0 and you multiply that by some number or try and reflect it, the coordinate will still be 0. So I would start with the origin. This is where my root graph starts. And over here is where my new graph starts. Well, I know that that point could not have been affected by a reflection, expansion, or compression. The only way that point could have moved is by moving left, right, or up, down. So clearly we can see that this point moved down by 2 and left by 1. The next thing I'm going to need to do is find another point on each graph that would correspond with each other. And some people say, well, how do I know which 2 points? I would just find a nice point that's easy to see. So there's going to be a couple different versions of the answer, but they are all technically the same as each other. They're just going to be off by certain factors. So for example, because we're dealing with a root x, and don't write this down, but this is the same as this, right? I can factor that 4 out because root 4 is equal to 2. So somebody might see this as a 2 and a vertical expansion by 2. Someone else might see it as a horizontal expansion by 1 over 4. For this graph, those are the same thing, okay? So if you're like, oh, but that's not how I saw it, think about what function you actually have here, and does that make sense? Does your answer actually equal the same as the answer that the back of the book's providing or that I have come up with in my answer key I'm giving you? Okay. So I already have my origin point, but another nice point might be this one here. Okay. I could also pick 4, 2. That's fine as well. Okay. So it doesn't actually matter which of those you pick. I'm going to pick this because it's nice and easy. The vertical distance between these 2 points here is 1, and the horizontal distance is also 1. So if I pick a second point on my new graph, this point here looks nice. My vertical distance between these 2 points is 2, and my horizontal distance is 1. What that means is there's been no horizontal expansion because the horizontal distances between my 2 points on each graph that correspond with each other are the same. But my vertical distance is different. On my new graph, it's 2. On my old graph, it's 1. That indicates a vertical expansion by 2. I also can see by looking at this that this has been reflected from the upper right quadrant. It has been reflected over the y-axis so that it's opening left instead of right. So everything's been flipped over this way over here. So since it's been reflected across the y-axis, that is a horizontal reflection, right? It's flipped over this way. Okay. If it had a vertical reflection, what happened? It would open down like this. So we've got a couple things that we can do to write our new function. So if I have some y equals f of x, if I have these different things happening, again, remember we're going to do expansions, compressions, reflections first. So a vertical expansion would be 2f of x. Right. If I reflect across the y-axis, that would be a horizontal reflection. That means my negative is going inside with the x because it's horizontal. I'm also moving down 2 and left 1. So left 1 would be x plus 1. Okay. Again, reminder, if you're moving to the left by 1, that's in a separate set of brackets with the x. I should have 2 sets of brackets there. One to isolate the coefficient of x and the other one for the moving left, right. And then I'm also moving down 2. So this means I have my vertical expansion by 2, my horizontal reflection, my left 1, and my down 2, all there. Okay, so if I write this as f of x, this would be my final answer. However, I also, in the question, I know that y equals root x. This means f of x is root x. So I could also apply this specifically to this function. So if this was a question on a test, you could leave it as the stuff in the red box, or you can actually use the root. So if I did that, I'd have y equals 2 root 2. This would be after my vertical expansion by 2. Oh, sorry, not 2 root 2, 2 root x. I apologize. Okay. Then if I add in my horizontal reflection, this becomes 2 root negative x. Okay. Then if I add in my moving left 1 and down 2, I end up with 2 root negative x plus 1 in brackets, and then minus 2 outside the root. So we can see here the difference is that I've got my negative 2 at the end, negative 2 at the end. That's the same. I've got my plus 1 in the middle, plus 1 in the middle. That's the same. I've got my minus in front, my minus in front. That's the same. I've got my 2 in front, 2 in front. That's the same. The difference here, let's pick a color that's easy to see. Let's go with this one. Okay. I've used an F here and I've used the root here. Okay. You should not be using both. A common mistake that I see is people will give me this as an answer on a test. They'll say y equals 2 f of root negative x plus 1 minus 2. We don't write this as y equals f of root x, right? We either write it as y equals f of x or y equals root x. It's one or the other. So we shouldn't all of a sudden, now that we're doing transformations, just magically include an f and a root. This is no good, okay? Pick one or the other. Either write it as f of x with those transformations or write it as root x with those transformations. Okay? Also, the amount of work that we have shown for this question is far more than you will actually need. Many of you will go straight from here to here to here. Some of you might go even straight once you have all your transformations, just go straight to the final answer. That's fine. Okay. I'm simply trying to show you every possible step for people who maybe are struggling how to come up with their answer. Okay. That is all for this section. Please make sure you do an abundance of practice questions. This one is definitely if you are not understanding it, more practice, the better. And you can always rewatch the video if you need, slow it down, pause it, etc.